Well, hi, good morning. Thanks so much for joining me here in my shop. I'm hoping today to do the last step of the calibration process on here, I think, which involves heater current and using the meter to read the actual current flow through the meter, through the tube filament. That's an interesting thing. Never gave it much consideration. I've never heard about problems with current flow through tubes other than open filament type problems. And but as it turns out, if you have one of those radios where you have 5 tubes in series, and one of those tubes heaters resistance has fluctuated, has gone down or gone up for some reason, let's say it goes up, then that tube's going to drop more voltage, it's going to dissipate more wattage, it's going to rob the other tubes while it itself cooks up. And apparently what I read, some old guy who used to do this, every day professionally, that was a common problem that you could track down if you had a tube tester like this. So that's why it's kind of neat to do this test. We're going to do it with a 6F6. I think that's the tube that we should use. So why don't we start by reviewing the instructions here. Okay, so the last step we just completed here, emission calibration, did not go well. So this is, I don't know what to do about this at this point. I'm going to skip over it. I am getting a new bias potentiometer, and I haven't given up my search for a 6L6. Maybe there's one hidden under my pillow somewhere in the house here, I don't know. So this is what we're going to do today. Filament current calibration. Here's the instructions. Rotate test switch to off. I might as well make sure of this right now. Remove leads going to grid and plate. Rotate meter switch to line. Adjust for center scale reading. Rotate meter switch to 3 amp. Adjust P12 on power supply chassis for reading of 0.9 on the 3 amp scale. A 6L6 draws about 900 milliamps. An AC ammeter placed in series with one of the 6L6 filament leads would of course be a better method of calibration. Method not listed due to scarcity of AC ammeters. Well, I certainly have an AC ammeter. So it looks like it's just a direct thing. If I can read the current directly going into a tube, then I can adjust the reading on the meter to match. Yeah, it's okay. Remove 6L6, rotate switch H to 5 and switch I to 6. Make certain test switches and off. Filament switch should be at 6.3. Insert 6C4 tube, rotate meter switch to line and adjust for center scale reading. Rotate meter switch to 0.3 amps. So there's two current scales, a 3 amp and a 0.3 amp, and they're trying to use tubes that draw appropriate currents so we need to use a tube that has a pretty good draw on it. It strikes me that almost any rectifier tube would put a pretty good draw on this. Now completed. So I think I got to figure out how to use the AC meter here and do this properly. What other easy way would there be? Yeah, I think I got to do that. Okay, let's figure out how to do that. How do you do that anyway? How do you break the feed to the filament in order to insert an ammeter? You have to take a wire right off somewhere, wouldn't you? That's easier said than done. Is it really worth doing this? If I had a tube whose current flow I knew, if I could find it somewhere else, and then knowing that, put it in here and test it. But I don't have any testers that will do anything, and none of them would be calibrated anyway. What if I apply a known voltage to the heater on a tube like this, and measure the current, and now I know that voltage produces that current. Now I know the current. Put it in here, make sure that voltage is on it. Should do it kind of the other way around. So this is running with an AC voltage though, and I don't really have a variable AC supply I could do that with. I could do it with DC. What would that get me? I can also measure the resistance of the filament, but that's of no value because the resistance varies with its temperature. So that is, I can't really do that. Well, how hard is it to take one wire off the socket, stick an ammeter in there? So the socket we're plugged into is this one. So there's a wire in and a wire out. So they've looped, the same wire all the way through all these terminals. So there's a feed into this from somewhere back in here. It's got to be on all these wires here. There's a bundle here, a bundle here. Could trace it back to a single point. Maybe I'm lucky in doing that. Let's see if I can be lucky in doing that. Now the filament power is brought to the correct pins here based on the settings on the front. The machine is set for a 6F6. So, oh, I have to grab my tube manual here. Using it for a little bit of light reading during the day yesterday. 6F6. 6F6. So the heaters are 2 and 7. I knew that. I didn't have to look it up. 2 and 7. So it's the red here. Making sure it's turned off, of course. 2 or 7 being this kind of brownish one. Well, these are really accessible. These two here. All I gotta do is just connect the one red wire, which is leading back, which is the supply wire. It's none of these. Just following that red wire. Oh my gosh, yeah. So it's reached this point, which is grounded. That's the wrong way. The other way, that didn't work, did it? This has to be the red wire here, I think. I need to poke at it. This wire here. I think I got the wrong wire. That's the wrong wire. Wow. They colored them, but the colors are really similar. There's orange, red, and pink in here. They all look the same pretty well. This wire here. Huh. Kind of a nicely done wiring job, but there's a horrendous soldering iron strike here. The insulation's all off. Now this is supposed to help with exactly this kind of thing. That's definitely not it. I think it's maybe this one. Okay, so that's it. That's the red wire. It's not. Wow. I don't know if I want to go in there and fiddle with that. Okay, another way is to cut the wire, reattach it here. This is a better way. This is a much better way. Now I got to figure out which way is the power coming in. I'm pretty sure it's coming in on that wire. It's eventually going around to ground. Yeah, okay, so we're going to cut this wire off the terminal, hook up an ammeter there, and see if we can't measure the current. Wow, if I had a couple more of these terminals here, I could make this a permanent thing. A couple of terminals with a jumper. Pull the jumper off, put the ammeter in. But I'm going to make this thing's ammeter work properly, so what do I need that for? These are very stiff wires here. Heavy conductors. Go ahead, Jim. It's the only way. Even if I had a 6L6, how would I know for sure its current was 900 milliamps? I wouldn't. Okay, I'm sure that's not going to harm anything. Now, to do an amp meter on that, you have to make a pretty darn good connection to the meter. Just a little clip things, it may be okay for voltage, but milliamps and amps. So on the milliamp scale, we'll go up to 200 milliamps. Let's put it in the amp scale. Can't go wrong there. There's fuses in here, I think. Unfused. Okay, so the 20 amp line is unfused, but that's okay. No chance of some serious problem occurring. And this should be on AC amps. 20 to start with. 20 and then 200 milliamps. Oops. Now, so I have a pair of better than average clip leads for this. Provided I can find them. We can use these heavy ones here. Let's do this. Let's use these. Sorry, these are like my best clip leads here. Still a little tricky to make a good current connection, so we're not going to use these. We're going to use these. That we're doing AC current, so there's no polarity issue, no grounding issue because I'm using this meter. Might as well turn it on. Why not? So one side continues on. So that's going to be a pretty good grip there. Now the other side's just onto this wire here. Well, we'll try that. If I do this test and I get a certain reading on here, I should leave this ammeter in the circuit and do the test and set up the other meter while this one's still operating. Because it could be when I remove these clips, the current's going to change. Just because of a changing of, just because I'm changing things. And then I'll end up calibrating the main meter, and I got this thing on its side, and I already know that that's a problem for the meter, so I can't do it like this. It's got to be laying flat. Good. That's good. That's not good. Stick with me, meter. Stick with me. We're going places. Okay. 6F6 is in there. This should be set up for the 6F6 EM test. Doesn't really matter as long as I have the right plate. All I really need is the right voltage on the filament. I don't need to put this into test mode or anything. I don't need to actually set any of this up. To take that back. What was in my head was correct, but what came out of my mouth not quite correct. Okay, I think we're ready to go. So what I'm going to be doing is let's just go over this quickly before I get it turned on and start getting mistakes. So rotate test switch to off, remove leads. Did that. Rotate meter switch to line. Adjust for center scale reading. Rotate meter switch then over to 3 amp. Adjust P12. Okay, so I look for P12. So I know where that is under here. So P12 is way over here. I need a little screwdriver to adjust it. To make the meter read the same as this one. What is the filament current in a 6F6? Good question. Let's see what it's supposed to be. 6F6. Hey, where's the heater current in here? Oh, here we are. Heater current 0.7 amps. That's pretty good. 700 milliamps. So we expect to see. Yeah, I got to be on the 20 amp scale here. It's the only way this is going to work. Okay, as soon as I turn this on, this thing should start showing. It might actually have a bit of a current rush in there. But I'm going to turn this on with dim lights. It's got its own dim light. That's enough dimming, isn't it? Switch is on here. We're on line, off, test, 6.3 volts, biases. So I'm going to turn it back like this a little bit. I think we're ready. And we see some current already over here. It's way low, but then then I read 700 milliamps. That's 50 milliamps. So we are on restricted voltage here. I put on full voltage. It should be 0.7. Okay, something is going really badly wrong. So I got the fuse light is on this. Something has gone totally wrong. Okay, maybe I've bunged up the settings here somehow. Let me 6F6. Just 1 second here while I hang on. Okay. 6F6. So I'm looking at the data for 6F6, the settings chart. I will be looking at it very soon, as soon as I get there. 6F6. CGGG. Okay, sorry to have a problem here. See, and I'm in EM mode. Let's follow this and we'll set it up, not for EM, but for transconductance. 26431, that's correct. 05200, that's correct. Supposed to aim for 1.7 bias, but it won't matter because all we're doing is heating this tube up. Yeah, right on the chart it says 0.7 amps for this tube. It's written right on the data chart for here. So 700 milliamps is what we're expecting here. Yikes. It's one single heater between pins 2 and 7. There's no center tap or anything funny like that going on. So maybe it's just this. This setting wasn't right. It's the plate shunt. I don't know how that would affect heater current, no idea. Let's go again. Am I not reading my meter right? How can I not be reading this right? 20 scale. It's got to be 20 for 20. Point should be 700. So I didn't get this meter connected quite properly. Low voltage, it raises it just a touch. Okay, so the fuse light is on over here. We're in line adjust mode. I'll bring the line down. Guess what? Bringing the line voltage down got rid of the fuse light. That's twice now I've noticed that. Okay, so line is adjusted correctly. Don't get your finger off that. Bias was supposed to be 1.7. So that's roughly 1.7 for what it's worth. Test mode, let's test it. Let's test it. No reason why we can't. Okay, so we're a little under 4 on the GM, which is in the range of what we've tested here before. The tube is getting warm. I've checked for shorts. I believe there's 2 positions where we get a short. 2, 7. That's normal. Everything's normal. Okay, well, we'll flip this over to 3 amp here and we'll see what we got on the meter. Okay, the meter came up. The 3 amp scale, this would be 0.5. So this is much closer than this. What's going wrong over here? And I'm tempted to flip this down to 200 milliamps, but if there really is 700 milliamps flowing, I'd probably pop the fuse that's in here. 315 milliamps max fused, it says. 315. Why not 300? So, hey, it's the same. The man with 2 meters never knows what the current is. Another meter. Another meter that can measure amps. I can do it with this other one right here. Okay, power off. Pull these out. Bring over my somewhat disliked meter here. Into the 10 amp. This is off now, so we don't have any problems here. 10 amps. Put this on the 10 amp scale. You have to flip past the milliamp scale. All these other scales you got to flip past. So you really shouldn't have these connected until you get this thing set. Really, it's not a winning meter for me. But we are set now. So we're expecting to see 0.700 there. Okay, this is still on the current scale here, that's fine. Let her rip. Okay, so it appears to say 10 amps AC or DC here. Something I'm supposed to do about that? out of the pan into the fire. Why didn't this read? The wire came off. No, this meter went up. I didn't wait long enough for this thing to figure out what it's supposed to do. Well, I'm going to pull this out and interrupt the current and see if this meter doesn't drop to 0. This is the best idea. That was my arm there. It's not. Here we go. Oh, guess what? It didn't drop to 0. Okay, something weird is going on here. Off, test. Clip leads look perfectly fine. You know, there is an off setting here, so you can turn the machine on into the highest current setting initially. So there is a way to avoid going through all those different settings. Well, I don't get it. It says auto. Seems to suggest it can figure out continuous and AC. Figure it out. There just isn't enough current. And you know, it's an automatic scaling meter too, which I find quite annoying. Also, well, let's try one more time. This is behaving just like a heater current. It went up, now it's falling back slowly. There's a 400 milliamp fuse in the more sensitive setting and a 10 amp fuse in the 10 amp setting. There's no chance I've popped that. I haven't popped that fuse. So both meters have failed to read. That's really what's happened here. And I've pulled this lead out and the current continues to flow supposedly into this tube. So I got something terribly wrong here with how I've wired this. That's what's happened. That's what's happened. Terribly wrong. I've done something stupid here. Let's see what I've done. What have you done that's dumb? So I'm making not an assumption, I made an assessment that suggested the power that reaches the filament comes in on this wire, goes through the filament, and then follows this red wire all the way around to this one. And this wire, it comes around to this terminal, which is then connected. Oh, is it really connected to Earth? No, that's not Earth. This is the light bulb testing point. That's what this is. There's a feature on a lot of tube testers where there's a socket. One of the larger tube sockets is designed so you can put a light bulb in there and quickly test it on the 6.3 volts. And that's what this is. So I got this backwards. But you would think, yeah, so I've interrupted the wrong wire. Exactly what this wire is doing. What is this wire doing? This wire is going back to that same point. Well, it's really the other wire. Interrupt the other wire. Try as I may, I think I just didn't assess it right. You know, come on, there's a lot of wires in this thing. reattach the other one. I'm going to leave them both open. I'm going to tie them both together if I can and put the clip on it. So there. Yeah, this isn't going to work very well. Pretty, you know, almost an amp through this. I don't know. You know, you're just conveying voltage pressures into your meter. That's one thing. You're actually trying to flow current through it. That's quite a different matter. I don't like how this is going. I want to do this so there's no doubt. No doubt. Okay. Let's see about that. Oh, not quite what I thought I was grabbing. There we are. So I have a number of these test leads that are bananas to bananas, and I never use them. They just never seem to come in handy. So I'm going to pull the ends off. Use this lead. I'm going to solder them right in here. Make it a solid connection. Okay, just solder the second wire here. Now, admittedly, the test lead wire here is a little thin for an amp. But I don't think it can be that bad. Thinking if the soldering iron slides, it's going to run into my thumb. Okay, just like that. Just like that. Come on. That's got to be good enough there. Ah! I let go too soon. Yeah, I turned on the video because I thought it would just be 2 seconds of soldering and away we'd go. There. Okay, so soldered in now. Only way any current gets to the filament is through one of these, both of these wires. Let's get off this meter, which I don't like. I am learning to dislike. Back to my tried and true buddy. I've had this guy a long time now. 10 amps, 20 amp scale. 0.7. Let's see it. Put this down. I can do that nicely now. No clip leads to worry about. Good. Excellent. Very good. Not only is this wire a little thin, but the connections up here are really poorly done. Now, a lot of these I've resoldered. I don't know about these. We'll find out what happens. Okay, I think we're ready. That's better. That's what we wanted right there. $600. So let's make sure. Now all I got to do is just match this meter to that. They don't have to be correct for the tube, in the sense that if the line voltage is off, it doesn't matter as long as these two read the same. But let's check the line voltage anyway. Anything happening there when I did that? Shouldn't. Line is low. so low? Because I've still got dim lights on. Still got dim lights on. Okay, line is full. Adjustment is correct. Yeah, it's very close now, isn't it? I wish I had another decimal place showing up on this meter. 0.68. Okay. Bias should not affect this test. Test, we're in test mode. What happens if we hit the test switch in test mode? Nothing, nothing. Maybe it dimmed a little bit. Might have gone down a touch. But I bet you if I watch the line voltage, when I put this into test, the line just dropped. The width of the needle wasn't much. Okay, back to current. Ready for the adjustment. Okay, ready for the adjustment. Let's get a good close look at this here. So it should be reading 0.67. On the 3 amp scale, it's reading 0.5. 0.5, 0.6, almost 0.7. Almost to there. Actually, look at the shadow from my screwdriver, okay? So that's where it's reading. 0.5, 0.6. That would be 0.7. We're heading for 0.67. So right in here, where you look at the shadow. On the right scale. Is everything right? Yeah, absolutely. So that's where we want to get it to, where the shadow is. Okay, let me get into the adjustment here. P12. Okay, now we're watching, and we're trying to move it to. Tell me this is dirty. So we're trying to get to where I pointed. It's right there. 0.67. That's it. That's 0.67. 0.67. That's correct. Okay, now we should do the other scale. The other scale top is 0.3. So we just can't do it with a 6F6. We got to put a lighter tube in. So we'll do it with a 6C4. That's great. Okay. Power off. I can't believe it. I actually calibrated something in this machine that actually seems to have worked. That's amazing. Six F6 number 1 out. 6C4. Right here. 6C4. Okay, I gotta set this guy up for a 6C4. Just keep it rolling. Keep it rolling. 6C. 6C4. Now see how I'm grabbing this with my fingers going underneath? Shame on me. Shame, shame. Shame. I'm gonna be taught a lesson here if I'm not careful. 6C4. Okay, 6C4. 6 point. I won't be taught a lesson with the power off though. The power's off right now. 6.3 E G G G E G G. Oh, this wasn't on G. Nah, leave her. G. Maybe it wasn't supposed to be. I don't know. 40. That's water under the bridge, Jim. Move on, move on. 506 50 12000. It's supposed to be 4.8 volts bias, but it won't matter again in this test. So 150 milliamps is what we're looking for here. So I should be able to go on the 200 milliamp scale when I'm ready. So I think that's it. So double checking. E, G, G, G. Shunt doesn't matter. 40650, 40650, 12000. Test mode off. 6.3 volts, in you go. Oh. Son of a gun. This is only hooked up to measure current going into pin 2 of this. Okay, so I need a tube I can plug in here with a smaller current. Right. Okay, gotta find one of those. Shouldn't take long. Well, that was pretty easy. It turns out a 50L6, of course, because of the very high voltage, has a low current, and the current happens to be 150 milliamps. So here's 50L6 number 1. Before I put it in, I'll reset this to 50L6. 50L6. 50. This is off right now. Yeah, 50. BGAG. BGAG. Oh, I hear somebody coming. 06431 06431 1 431 06431 06431. Herein lies the difference with a 6L6 as opposed to a 50L6. 6L6, this control is set differently. That's the only difference on the machine here. 0505200. One of the reasons a lot of airplanes crash is because the pilots get distracted. He says distracting himself right on the spot. Yeah. Oh, I've crashed my airplane so many times. So I think we're ready. 50L6. We're on the 50 here. Test. Current. Hey, put the tube in. Need the tube in. And let me just, yeah, it's going to be a 2 and a 7 here. Good. Away we go. So it jumped up to 1/4 amp there right away. It's kind of interesting. That jumped up with restrictions on. It would have jumped up quite a bit higher, I think. It's managed to get to where it's supposed to be. Shouldn't be there, should be below. Everything's good. Full. We go full. Let's see what it settles in at. Looks like it's going to come in at 150. Okay, let's adjust the line voltage. It's not pretty good. I want to make sure that you're kind of always starting from the same place. Look at that, 150. Bias doesn't matter. Test, we won't do it. Yeah, let's do the test. Why wouldn't we do the test? I haven't set the bias. Bias is supposed to be 1.4. Yeah, I'm starting to get good at this. Just starting. Test. Current. Okay, just barely up on the 3 scale, on the 0.3 scale. So on the 0.3 scale, we're above. So there might be another adjustment now. Hey, who opened the door here? Was there a cat in here? Did a cat come in here? Let's just check quickly on. Yes, I was distracted. What am I adjusting? That's right. What am I doing? Why am I even here? Okay. P13 to get 1.5. Okay. P13. P13. We're trying to get oops, let's try it like that. So that should be straight up if everything is correct. We're going to check the line again. Bias line. the money. As much of the money as we can get on. 0.3. P13. A little bit awkward to get to. There. Okay, we're in P13 and adjusting it. A little bit of backlash in this control. There we are. Fantastic. Okay. Well, I got that part working right, I'm pretty sure. I think we can probably really rely on this for current flow through the tubes. And the first 2 tubes I've tested have correct current flow. Hey, should we test a bunch more? Why did I do that? I've got 5 of these guys labeled. You just pop them in and out. Let's do that. We'll just keep an eye on the... here, I'll do something just a wee bit fancy here. Okay, that came out kind of cooler than I expected. Okay, so I'm just going to pull the tube out. It should drop to 0, and the meter should drop to 0. Pop another tube in. I'm not going to change anything. Is that a smart move? Just leaving this here? It's not on test. I don't think that's a problem. Famous last words. Hey, come on, meter. Don't go to sleep on me right in the middle of it. At least you don't cry out as you turn off. Okay, come out. That's number 1. Here's number 2. You get a chance to see the inrush current here too. Full supply available. So this is what happens when you turn on this radio. Turn on this to 4. See that? It's half an amp was there. Half an amp was there. Hey, what's going on? The other meter's stuck. Ooh. China syndrome, that's what that is. So this one's just a little higher, is it? Yeah, let her warm right up this time. That's the only way to get this. So in the indicating meter you can see the variation, but on the digital meter, of course, you can't, because it's quantized, as opposed to analog. I wish I had a more precise meter here. I could switch back to this one. I think I get 1 more decimal point with this one. It's probably a decimal point of baloney though. Okay, so I think that's it. So this tube is drawing a little more current, unless something has happened here in the test setup. Maybe the line adjust. I can go all the way there. So the line adjust is a little low, if anything. That indicates the tube is drawing a little more. It all indicates. So if I check, I got wrong control again. So there's the line adjust, that on. So this tube is registering a touch more current. Exactly how much more? Well, that's supposed to be 1.5, so it's close to 1.6. So 0.1 in 1.5 is 1 in 15. Well, that's like a 10% error. Not quite. Okay, next tube. So how long? This eventually got down to 150 on that meter, or 1.5. Take tube number 3. 1, 2, 3. Here's 3. Okay, going in. Trying not to get a shock while I'm doing it. Didn't see what it went up to, but I'm guessing it went up the same way the last one. This meter's stuck again. One of these days I'm going to tap that, it's not going to come down. That's a good reason to take the meter off the at least the 0.3 amp setting, so it doesn't slam up there every time I do this. So I don't think this is going to make it right to the... So, you know, according to this meter, it's fine. And according to this meter... So this is like the second tube that reads a little high. Okay, so it's reading a little high, but I mean, we're not talking about anything significant. Let me go back to tube number 1 and see if it's reading high now too, just in case something has happened here that cannot. Oh, I made that mistake again. I gotta stop that. Every time the test is done, put this to a neutral place. Neutral place being, for instance, the test position. And the test position is neutral until somebody does something with this. That's got to be the rule from now on. So this one's reading a little high now too. So I'll bet you the adjustment just kind of relaxed into its final position. Not that this kind of accuracy is really required. Well, let's do it. Okay. Yeah, see, there's a lot of backlash on this control. So, you know, is it going to really stay there? There it is. And that be it. Okay, off of number 1. So these have all tested exactly the same. Tremendous consistency coming here. This is number 4. Oh, I did it again. Come on, man. I just finished. I'll have to go sit in the corner. Where the dunce hat. Did you guys have a dunce hat in your... We did. Yeah, a teacher actually forced kids to sit in the corner with a dunce hat on. Unbelievable, eh? To me, the rule is you can't treat children any different than you treat adults when it comes to stuff like that. Would you ever tell an adult to go sit in the corner with a dunce hat on? I can think of a few, come to think of it. Okay, so this guy settled out a little high again. And, you know, once again, I'm wondering, is this just the meter doing its thing? Yeah. So we're going to pull this out. Number 1's going back in. Oh, I've done it again. I'm chuckling now, but if that meter doesn't come down one of these times, look, it's gone high again, I think. So, name again, maybe I'll look at this little yellow area up here where the question mark is and say, you know, that's kind of the range of this meter, kind of the accuracy range, if you like. So anywhere in the yellow is the same as 10 or 1.5, which is what I'm actually after, the 1.5 there. Maybe that's the way to look at this thing. Pretty darn close. I mean, there's nothing, I mean, you could tell there's nothing wrong with it too. If you put it in there and get this kind of reading, you'd say, yeah, that's just fine. Okay, one last tube, number 5. Number 5, where's number 5? I had it. Here it is. Number 5, last one. Maybe this one will be exciting. So problems with the heater current flow would be of most concern when the heaters are in series. If the heaters are not in series, if they're in parallel like they are in many radios, if one of them is for some reason drawing more current than it should, I did it again, didn't I? Then that wouldn't really matter. It's when they're in series that could become a serious concern. A series concern. That's my joke of the day. Now this one, so this one's coming in. Oh, look, it's a little low on here. Let's check the line. Check the line. Okay, the line is a little high, if anything. So here we actually have a tube that's different than the others. And the difference, you know, it's within that yellow range, if you like, which shows the kind of suggests the error range in this meter. Would I say something's wrong with this tube at this point? Having not seen that? No. Is there anything wrong with this tube? Heater current? No. Perfect. She's a beauty. Why not test it? So the test is coming up just under 4. So quick check on current. Coming down towards the proper range. 1.6 on the digital meter. Slow poke. Okay, and we test it. Oh, you know what? You know what's going on here? I think the line is probably high. Oh, not by much. Okay. Bias. If you're doing the GM test, you got to set the bias Jimbo. Oh, it is 1.4. Is that what it's supposed to be for a 6? 1.4. Luckily, I do have it set. GM test. So that guy's 5, a little over 5,000. It's a little better. So the other one had low current flow in the heater and low, slightly low GM. Number 3. Now I did all these and I wrote the results down before. Number 1 being the best. I think they're written right in here, aren't they? Right in here. Here they are. Here they are right here. So tube number 3, last time tested was 3,000 on this tester. 3,000. This time, oh, what happened there? That was a bad test. It barely even made it up on the scale here. It went up and then just kind of relaxed down to 2. Oh, why is it going up? Why did it go up? Still warming up. Really? Bias 1.4. Line. Touch high, but good enough. Test. Slowly going up. So, you know, this might be indications of some other thing going on with this tube that tubes in which I am not that familiar with particular gas in the tube. I have always kind of thought to myself that gas in a tube means a shattered glass globe. So the only way you'd find gas in a tube is because there's a crack, and that's not a good assumption. Not a good assumption at all. Okay, on to the next one. Because that one last time tested at 3,000. This time, say 2,500. Tube number 2. Number 2. There's number 2. Here's 2. I didn't pin the meter this time. Isn't that good? I think so. Tube is in. I can check the line again. Check the bias. Let's check the filament current. Shows a little high. It's 1.5 on the digital meter. It's within the yellow there. I should be saying to myself, that's just fine. Necessarily tiny variations in filament current can't be significant in the operation of a tube. I mean, the temperature of the filament up or down a few percent, that just can't matter at all. So, test. Last test on tube 2, 3,500. This time around, 40, 45 and falling. Different readings every time. And now to the official tube number 1. My number 1 man here. So I'm kind of testing everything under the sun here when I do this. I'm testing the tester, I'm testing the tube, I'm testing myself, I'm testing the whole concept of doing tube testing in a way. I'm doing multiple tubes of the same one. Okay, let's try current through the filament. Pretty much right on. Nothing wrong with that tube, that's what I would say. 1.4 bias, good. Line, good all around. Test mode. This one measured 5,000. Number 1 was 5,000 last time around. Oh! What happened? Did we burn it out? Have we burnt it out since then? Isn't that something? A little bias sensitivity, not terribly sensitive. Resetting the bias. So moving at about a half a volt there when I was doing that little sensitivity thing. Test on hold. Well, I don't know, we burned this guy out. I'm going over to tube number 4 now because tube number 4 actually had the highest reading last time around, 54. Let's put it back in there. I mean, the first time I tested these tubes, I had not done anything to the tube tester. Since then, I've done all kinds of terrible things to it. Anybody surprised that it works differently? I am not. We're almost there. Current through the filament. Ooh, this guy's really sucking it back. Man alive. Line. Bias. Bias looks good. Test. Are you 5400? Oh wow, 52. And I can get to 54 if I just turn the bias. Let's just see how far I have to turn it. So I get 54, the bias there, and when I've actually set the bias to now, instead of 1.4, it's 1.6. Not much different. So you can see the bias calibration and things like that I've done along the way may have shifted a few of these readings. But that's pretty similar, right? Great. Okay. Power off. That's the end of the road for the very first time through the entire calibration process for this guy. So what's happening here is I'm going to be away for about a week. I'm going to be in Ottawa practicing as a grandfather. I'm going to have my first chance to go and be a grandfather. So I'll be away for a week, no videos for probably 7 or 8 days, starting this weekend. By the time I get back here, hopefully the new rheostat has arrived from England. I'll be able to install it, and hopefully that'll eliminate any issues around the bias situation. It'll then run through the whole calibration process once again from start to finish. I'm thoroughly familiar with it. I think I've made just about every mistake you can make. Oh, probably not. I need to learn the gas test. I want to get good at that. There's gas tests on the other testers, at least one of them. There's also a noise test, which I have on another tester. This is kind of an unusual sort of thing. So I have lots more to play around with, and still more areas to get familiar with. But I think basically, as this machine stands now, even with the rheostat switched around, this is actually a usable, working, reliable machine. That's what I believe. It's the same grade anyway as my other two testers in terms of reliability. And then ultimately, we're going to get into a comparison deal between testers and tubes, and we're going to go wild. We're going to go wild in here. Yeah, when I get back from Ottawa. Ottawa is the capital of Canada. Ottawa has the highest temperature range during the year of any capital city in the world. It's colder there and hotter there than anywhere else. No, that's not quite said right, but I think you know what I'm getting at. So, so that's it for In the Shop today. Thanks a lot for watching. I'll be in here again tomorrow, and I haven't decided yet what I'm going to do. What am I going to do? I don't know. See ya.